Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of quadratic domain and range. This is standard A.6A in the great state of Texas, and we are using item number 43 off the 2021 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a quadratic function graphed here, and we are looking for the domain and the range. Now, unfortunately, these two terms are not going to show up in your reference materials. They're not going to show up on your STAAR chart. If you don't know the definition for these two, then there's really not much of anything in this problem itself that can give you the context clues to figure it out. We just have to know domain and range. So let's define them. So the domain is the set of all possible independent variable values. And when we are thinking of that, typically we think of shorthand as our x values. So if the range is the set of all independent variable values, that means our domain is the independent variable values. The range is going to be the dependent variable values. Now those can go by a few different names. So in shorthand, we typically think of the range as the y values, but sometimes I've seen them as f of x or g of x, h of x. So that's why we don't always say, oh, they're just the y values. Most of the time they are, but sometimes they're the f of x or g of x if the problem is set up to really highlight the fact that it's a function. So knowing that, let's put that on our graph here. Our domain is going to be our side-to-side horizontal x values, and then our range is going to be our up and down vertical y values. Now, domain is usually the easiest one to find because unless you get some type of graph like this, now sometimes you'll see a graph like this and it's kind of like a broken part of a parabola. They'll kind of chop off either end. That has a restricted domain. That goes from this point to this point. But just a traditional parabola, like we have here, is going to extend with all possible values. Now, this particular graph goes to about, stops at about 1.4 and negative 7.4. But that doesn't mean that's where it stops. That just means that's where this particular graph, the way we have it zoomed, will stop. If we were to zoom out on that graph, we would see it get wider, zoom out again, get wider, zoom out again, get wider. We can zoom out infinitely and it would infinitely get wider. So most domains, if it's a regular parabola, are going to be the values less than infinity and greater than negative infinity. Or if you want to just put in words, all real numbers. I've seen it both ways. Most of the time it's going to be this all real numbers, the written version, rather than the mathematical inequality there. And so we see domain all real numbers right here, and that's it. So we can really eliminate all the other ones just by finding the domain. It's not restricted to just greater than negative 3. So that knocks out A and C. And then it's definitely, this is not going to work. Look at that, domain of y. The domain is the x values. So D is wrong just because well, first off, it's wrong, but it also mixes up the y and the x values. So let's check the range just to make sure we got it right. So the range always is going to have, if it's a parabola, some restrictions. You need to find the vertex. Okay, so vertex, and it's going to be all real numbers greater than that. If it's an upward facing parabola like this, it's going to be all real numbers less than that if it's a downward facing. So y, it's upward facing, is going to be greater than or equal to, and it's right there at 5. And so, yep, that's where we have it right there. Now, we did have that also on A, but remember the domain is wrong. So just finding that domain really lets us find the answer of B.